Hello, welcome to this course on applied linear algebra for electrical engineering. This course is being offered online this semester, and so I'll be recording lectures and posting these videos and the slides on the course website. You'll be expected to look at them, look at the video, look at the slides and learn from them primarily. My name is Andrew Thangaraj, and let me begin with information about the course. So this page has most of the information that would be important for people in this class. First of all, the title of the course and the number of the course. It's E5120 Applied Linear Algebra 1 for EE. I am the instructor, Andrew Thangaraj, and in the slide version, you can click on my name, go to my website, click on the email to get to the send an email to me if you want to. The semester that I'm teaching this course is the August-November semester, and it's being taught online completely because of the limitations for students to come to campus. The section I'm dealing with here is basically for continuing students. So this course is primarily taught for entering MS and PhD students and some advanced undergraduate students who want to take it as an elective. So the students who are continuing, say, people who are in third year undergraduate, fourth year undergraduate, or say second year and third year of their PG programs, they are expected to be in this section. The section which is going to have the new entering PG students is a separate section. It's being taught by another faculty in this semester. So let me begin with the textbooks. The most important textbook for this course is the first one that's written down here, Linear Algebra Done Right by Sheldon Axler. That's the one which is most important. The one that's right here, Linear Algebra Done Right. I don't think there is a cheap edition of this book in the Indian edition, but I'm hoping you can get it from somewhere, and also maybe buy the book if possible. It's a very good book. Okay. There are a few other reference textbooks which would be probably useful for you. One is Gilbert Strang's Introduction to Linear Algebra, and also there is another book by the same author, Gilbert Strang, on linear algebra and its applications. Both these books are very good as well. You could buy them and look at them. But we will be really following Sheldon Axler's method and philosophy of doing linear algebra. The last book I want to put down is Linear Algebra by Serge Lang. It's a very classic textbook once again. You should be able to get that as well. So these are the books we'll use. This course has a couple of prerequisites. The first prerequisite is a familiarity with basic calculus. And the second prerequisite is, I'll assume you have already done some sort of a first course in vector spaces, linear algebra, etc. as part of another course maybe. So the term vectors and scalars and magnitude, direction, all these things are sort of familiar to you. You've seen it once before. Maybe you've seen how a linear equation is to be solved, a system of linear equation is to be solved before. Maybe you learned the method by heart. Maybe you didn't know the philosophy of why it works, etc. But I'm assuming some familiarity with the basics of linear algebra already. So this is like a second course in linear algebra that you're doing. Okay, so it's likely to be very different from the first one, and a basic familiarity will be assumed. Okay, how are we going to be grading this course? There is going to be two quizzes, quiz 1 and quiz 2, 20 marks each, and an assignment which will also be 20 marks each, 20 marks, and then the final exam which will be for 40 marks. Now a couple of comments about this particular semester. The quiz 1 and quiz 2 and the assignments and the final exam for that matter, it's not very clear how we are going to administer it. I will try and do some way of administering the quizzes if possible. But if things don't work out, if it turns out that there are students in the class who do not have online access, etc., it's really difficult for people to write these exams online, then we will have the exams only when you come on campus. Okay, so this primarily this instruction is the material is being given to you for you to study, and the exams will happen whenever it's convenient. Okay, hope that's clear to you. All right, so that's course information, and of course, if you have any questions for me, you will have to use click on that email when I share the slides with you. You can click on that email and write to me. My email is andrew@ee.iitm.ac.in. Okay, so more details on what the syllabus is. So this is a sheet which has the syllabus. I will also share the sheet with you separately. You can also see the link from here. So you can see what we'll be studying, vectors and vector spaces. To begin with, we'll do initial coverage of what it needs to be done, what needs to be done in the area. I'll go through this a little bit fast because I'm assuming once again you have a familiarity with these ideas. I'll only emphasize the points which maybe are a bit different from what you have learnt before. Okay. And the next week will be on, we'll start off linear maps. Okay, linear maps are the crucial idea in linear algebra. How to study linear maps, how to think of linear maps, what is the connection between matrix and a linear map, what is the determinant, how does it relate to everything, what are eigenvalues, eigenvectors, everything is related to linear maps. So linear algebra pretty much is a study of linear maps more than study of vectors. Okay. Of course, they're both related. So that's what we'll be doing for several weeks, some 3 weeks in a row. As part of it, we'll also look at solving linear equations, changing bases, etc. And then we'll move on to eigenvalues, eigenvectors, which are basically ways of studying linear operators, how to simplify them, etc. And look at some applications of eigenvalues. And finally, in the second half of the course, we'll move towards inner product spaces, vector spaces which have an inner product, what are the properties that they satisfy, and some special types of operations, particularly projection, least squares, and then adjoint and self-adjoint, normal operators, symmetric operators, all these type of various special type of operators. And finally, we'll close with very popular decompositions, including the singular value decomposition. So it's a very heavy course. At the outset, I should tell you that there's lots of new ideas that we'll be studying. But it's also very, very useful course. These ideas are used across so many disciplines and so many different subject areas. I mean, the applications are limitless in this for this, and it's sort of a core area now for the electrical engineering. So linear algebra and probability are part and parcel of electrical engineering today. So you should have a very good command of all these basic ideas. Okay, so that's the syllabus. If the sheet is a live sheet which is embedded into this presentation, so as I change the sheet, it will reflect here as well. So you will have the latest syllabus with you at any time.